Okay, part 2 of chapter 17, number 45. So we left off calculating the moles of each one of these things. So we got our weak acid and we have our strong base. So initially I have 0.00525 moles of our weak acid, and we're adding, so our addition is going to be 0.0025 moles of NaOH. Now I know that when these react, they react in a 1-to-1 ratio because I have 1 mole of OH for each mole of NaOH, and I have 1 mole of H plus for every mole of acetic acid. And so all I need to do is subtract these from each other and figure out what's left over. So when I subtract 0.0025 from 0.00525, I get 0.00275 moles of acetic acid left over, 0 NaOH left over, and I know 0.0025 of acetate was created. And water we don't really care about because it doesn't do anything. Awesome. So now I have my acetic acid and its conjugate base, and I know the concentrations of this after we add our NaOH. The next step is actually going to be, you could make an ice table, you don't really need to, but here you can see in our equation we don't have OH or H plus at after addition, right? We don't have any of those concentrations. Now we need to calculate our pH, so it's going to become important. I know that my Ka for this is 1.8 times 10 to the negative fifth. And this is equivalent to the concentration of my product, so my conjugate base times H plus over my reactant, which was the acetic acid. And so just to illustrate that, so basically we could just solve for H plus. So to illustrate that, I'll just come up with a quick ice table. So ice H3, COOH. So at this point, oops, we're looking at this one down here, we have 0.00275 moles. Now, I know when I do my ice table, things should be in molarity, and especially when I calculate my H plus using a Ka. So when we plug it into our ice table, we can just convert this into moles per liter. And so I know here I have 35 milliliters plus 17.5 milliliters. So I'm just going to add both of these up, and that gives me 0.035 plus 0.175. And that gives me 0.0525 liters. So I'm going to plug all these numbers in. So this would be 0.00275 divided by 0.0525. So that's moles per liter. And that gives us 0.0523 moles per liter there. Oops, I'm sorry, this is down here. 0.0523 moles per liter. So H plus we don't know, that's X. And here we know that this is 0.0025 divided by 0.0525. And that gives me 0.0476 moles per liter. Okay, so all of this stuff isn't important. I guess what's important is this. At equilibrium, once we've added our base, this is our equation for the dissociation of acetic acid. And so now we can use our Ka, which is 1.8 times 10 to the negative fifth. I know that's equivalent to x times 0.476 divided by 0.523. And when I multiply all of this out, I get that x is equal to 1.9 times 10 to the negative 5. And the pH, therefore, is going to be 4.7 from using this, getting the negative log of x. So pH is 4.7. So that's how you do it. So again, you don't really need to set up this whole ice table, just kind of you understand that after addition, that's kind of where you're at equilibrium after adding the base. But you need to get the dissociation for the acid equation to solve for x, and then get the pH. And you can really solve for the pH any which way you choose. So you could solve it somehow if you needed to by finding the OH, by using KW. So there's all kinds of things that you can do. So it just goes back to chapter 15 and 16, and any way you can solve the problem, you can. There might not be one right way.